Hello. Hello and welcome to this video. We will continue where we left off in Python, that is collections.abc. ABC stands for abstract base classes for containers. So we will cover theory in this video. We should be able to finish this today and we will look at the practical in the next video. So without further ado, let's get started with this video. This module provides abstract base classes that can be used to test whether a class provides a particular interface, for example, whether it is hashable or whether it is a mapping. An is subclass or is instance test for an interface works in one of three ways. One, a newly written class can inherit directly from one of the abstract base classes. The class must supply the required abstract methods. The remaining mixin methods come from inheritance and can be overridden if desired. Other methods may be added as needed. So inherit from sequence. So init is an extra method not required by ABC. Get item required abstract method. Length is the required abstract method. And count is optionally override a mixin method. Now is C a subclass of sequence? It is true. And is the object of C an instance of sequence? That is also true. Existing classes and built-in classes can be registered as virtual classes of the ABCs. Those classes should define the full API, including all of the abstract methods and all of the mixin methods. This lets users rely on each subclass or each instance test to determine whether the full interface is supported. The exception to this rule is for methods that are automatically inferred from the rest of the API. So we have a class D, we have init constructor, get item, which is abstract method, length is abstract method, count and index are mixin methods, and then you register it as a class of sequence type. Okay, so you register instead of inherit, and again subclass and as instance methods will return true. In this example, class D does not need to define, contains, iter, and reverse because the n operator and iteration logic and the reverse function automatically fall back to using that item and learn. Some simple interfaces are directly recognized by the presence of the required methods unless those have been set to none. So we have a class E and we have iter and next, and is it a subclass of iterable? Then yes, it is true, and as an instance it is an object of iterable. That is also true. Complex interfaces do not support this last technique because an interface is more than just the presence of method names. Interfaces specify semantics and relationship between methods that cannot be referred solely from the presence of specific method names. For example, knowing that a class supplies get item, learn, and iter is insufficient for distinguishing a sequence from a mapping. So we have following ABCs. Container, if the abstract method contains, hashable has hash, iterable has iter, iterator has inherits from iterable and has next in iter, reversible inherits from iterable and has reverse method, generator inherits from iterator, has send, show, close, iter, and next. Now these are mixin methods. Then we have side, so that will have the learn method, abstract method, callable will have call. I mean, you need to implement these methods, abstract methods you need to implement when you inherit from these, or otherwise register them. Then we have collection, which inherits from side, iterable, and container, and abstract method are contains, iter, and learn. Sequence, it inherits from reversible and collection, and has get item and learn method. So you can go through this table. It is pointless for me to go through this table. Some of it is advanced. For example, we have not yet touched about asynchronous operation of Python, so this we will cover later. Okay. Then we have footnotes for here. So there are several footnotes. So 1, 2, 3. That is whatever footnote is designated by this one. These ABC overrides subclass hook to support testing and interface by verifying the required methods are present and have not been set to none. This only works for simple interfaces. Most more complex interfaces require registration or direct subclassing. Checking is instance object from iterable object class detects classes that are registered as a table or that have an iter method, but it does not detect classes that iterate with getItem method. The only reliable way to determine whether the object is a table is to call iter on object. So we have detailed descriptions. So this you can study along with the this table. Okay, so it is quite some common. So we will read what is extra here. For example, abc.iterable. Checking is instance subject comma iterable. This we have already read through. Generator is extends iterators with send, throw, and close methods. C. Annotating generators and coroutines for detail on using generator in type annotations. ABCs for read-only and mutable sequences. These are ABCs for read-only and mutable sequences. There is an implementation note. Some of the mixing methods such as iter, reverse, and index make repeated call to the underlying getItem method. Consequently, if getItem is implemented with constant access speed, the mixing methods will have linear performance. However, if the underlying method is linear, the mixins will have quadratic performance and will likely need to be overridden. Then we have index, which returns first index of value. Raises value error if the value is not present. Supporting the start and stop arguments is optional but recommended. Then we have some deprecation information which we can skip. And then we have awaitable methods. So this part of async and coroutines, we will not go through this. And do not forget to remind me that we need to go through this once we have done through async and coroutines. Then we have some examples and recipes. ABCs allow us to ask classes or instances if they provide particular functionality. For example, size is equal to none if its instance myvar collection.abc.side size is equal to len myvar. Several of the ABCs are also useful as mixins and make it easier to develop classes supporting container APIs. For example, to write class supporting the full set API, it is only necessary to supply the three underlying abstract methods contains, iter, and len. The ABC supplies the remaining methods such as and is discount. So for example, list-based set you can implement by inheriting from collections.abc.set. You can initialize with an table. Self.elements is a list. You initialize with empty list. And for each value in the table, if the value is not in list, you append this to the list. An iter is you iter on the list. Contains is you test for existence of the value in the elements list, and length is the length of the list. So list-based set will give you this. So you have the AND operation provided for you from the abc.set class. Now, why this is not good is because this is a linear access. Okay, sets will not do linear access for contains operation on set. Notes on using set and multi-mutable set as mixins. Since some set operations create new sets, the default mixin methods need a way to create new instances from a table. The class constructor is assumed to have a signature in the form class name table. That assumption is factored out to an internal class method called from table. Notice the extra underscore, which calls class able to produce a new set. If the set mixin is being used in a class with a different constructor signature, we will need to override from a table with a class method or regular method that can construct new instances from an table argument. To override the comparisons, presumably for speed as the semantics are fixed, we define less than and greater than, less than and equal and greater than and equal. Then the other operations will automatically follow suit. The set mixin provides underscore hash method to compute a hash value for the set. However, underscore hash underscore is not defined because not all sets are hashable or immutable. Create the hashability using mixin, inherit from both set and hashable, and then define hash is equal to set dot hash. So with this, we end the theory of abstract-based classes. So there are quite a few useful classes in this, and you can inherit from them or register to them to make useful user classes and objects of your own. So this was a small documentation relatively, but there are a huge number of classes. So expect long example in the next video, which I will create. And I think I'll end this here. So we will meet again on the fourth day with an example of abstract-based classes and how we can construct user classes from them for use in our code. So I thank you for watching the video, and I'll take my leave here. We will meet in the next one. Till then, be curious, keep learning, and enjoy.